Myself, I'm A. Srinivaslu. I'm having complete 10 plus years of experience. In that 7 plus years of experience on Java J2EE, 7 plus years of experience on Java J2EE, Java J2EE, and I worked on web services, Spring, etc. And last to 3.5 years, around 4 years onwards, I'm working on Hadoop and Spark and Scala. Spark and Scala, I have complete 1.5 years experience. So complete 1.5 years of experience on Spark using Java and Scala. I have both experience on Java, Scala. So last 1.5 years I'm working with Java plus, Hadoop plus Spark and Scala. Okay, integration with Java projects. Okay, so let's start Spark. So what is Spark? First, Spark is a big data processing engine. Spark is a big data processing engine. Big data processing engine. Big data processing engine. We have already MapReduce technology. MapReduce. So MapReduce is a big data processing engine. Big data processing engine. We have already one technology called MapReduce. It is also a big data processing engine. Why we are going for Spark? So first let's see, MapReduce is a Hadoop technology, right? MapReduce is a Hadoop technology, and Hadoop has mainly two core components. One is HDFS and another one is MapReduce. So HDFS is for storage, and it supports unlimited storage. Unlimited storage. So there is no limitation for Hadoop. You can store any size of data into Hadoop. So this is biggest plus point of Hadoop. And next one, MapReduce is a processing engine. MapReduce is a processing engine, and it processes data in parallel manner. Parallel. It processing data in parallel. So we have already MapReduce technology, which process huge volumes of data in a parallel processing manner. Then why we are going for Spark? Already we have a technology called MapReduce. Then why we are moving to Spark means, first, MapReduce is tightly coupled with HDFS file system. HDFS file system. First one, it is tightly coupled with HDFS file system. But Spark is not tightly coupled with HDFS file system. But Spark is not tightly coupled with HDFS. It can process any kind of data. It can process any kind of data, any file system data, any file system data, any file system data. It is not tightly coupled with HDFS file system. And next one, see, I said Hadoop has mainly two core components, right? What are they? HDFS and MapReduce. HDFS and MapReduce. HDFS is for completely storage. Yep. So MapReduce is processing, and HDFS for storage. HDFS is storage, and MapReduce can process structured data, semi-structured data, and it can process unstructured data. unstructured data. It can process all these kind of data. So here only one thing is we have to use any one programming language to implement MapReduce. So to resolve this problem, Hadoop introduces frameworks like Pig. Pig is processing. It can process these three kinds of data. It can process structured data, it can process semi-structured data, it can process unstructured data. There is one more technology called Hive. Process Hive can process structure and semi-structure, structure and semi-structure, semi-structured data. So these are the different frameworks we have. And coming to MapReduce we can implement in Java. MapReduce we can implement in Java, and we can implement in some other languages. It also supports Python. It also supports some other languages, but recommended is Java. Yep, that's what I am coming. So here pig pig is pig and Hive follows structure format. So coming to MapReduce we implement in any one language. That's what I'm coming here. So MapReduce we implement in using by any one language. It supports many languages. So it supports Java, it supports Python, it supports Shell script, it supports some other languages also. But recommended is Java. Recommended is Java because because it is implemented in because it is implemented in Java. So you can write using any language, but it is recommended to implement in Java. We have other frameworks in Hadoop called and Hive, Pig and Hive. These Pig and Hive has its own languages called Pig has Pig Latin and Hive has HQL, High Query Language, HQL, High Query Language. Pig and Hive has its own languages. So these are similar to SQL language. These are similar to SQL language. So Pig Latin and SQL languages are similar to SQL language. So compared to Java language, SQL language is simple and it easy to learn. So that's why a non-programmer also can work on Hadoop by using these frameworks. So non-programmer also can work on Hadoop by using these technologies. So this is the main advantage of Pig and Hive. But the only one thing is once we write, once we execute these queries, once we execute Pig Latin queries, Pig Latin queries or Hive queries, Hive queries, internally, 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 these are converted to MapReduce programs. These are converted to MapReduce programs. So all these, whatever the queries we are writing by using Pig or Hive, these are again converted to MapReduce programs. Okay. So let's see the differences why we are going for, instead of MapReduce, why we are going for Spark. So first, MapReduce process what? MapReduce can process structured data and semi-structured data, and it can process what? Unstructured data. MapReduce can process unstructured data. It can process three kinds of data. Spark also Spark also can process what? Can process these three kinds of data. It can process structured data, it can process semi-structured data, it can process unstructured data. So both MapReduce and Spark process structured data, semi-structured data, and unstructured data. And coming to second point, second difference, MapReduce is recommended to implement in Java. MapReduce is recommended to implement in Java. It supports many languages. It supports many languages, many languages, but recommended is Java, because it is implemented in Java, because Hadoop is implemented in Java. Implemented in Java. Assume if you are writing MapReduce applications using Python language. Assume if you are implementing MapReduce applications in Python language. There is a concept called Hadoop streaming. So we submit Python application to Hadoop streaming. Hadoop streaming converts this Python code into bytecode. Bytecode means finally it is converted to Java code only. So that's why it is recommended to implement MapReduce applications in Java. Okay. Spark we can implement in Spark. Spark we can implement in 4 languages. We can implement in 4 languages: Scala, Java, Python, and partially it is supporting R language. Partial supporting, not completely supporting R. Spark is supporting Scala, Java, Python, and partially R language. But recommended is Scala. Recommended is Scala, because Spark is implemented in Scala. Spark is implemented in Scala. Spark is implemented in Scala. So you can implement a Spark in Python, Spark in Java, Spark in Scala, but recommended to implement in Scala because Spark is implemented in Scala. So that's the reason we go for Spark. Once we write Spark programs in Python, once we run Python internally, again it is converted to Scala programs, Scala code. That's why it is recommended to implement in Scala. You can implement either in Scala, you can implement in Java, you can implement in Python, you can also implement in R, but recommended language is Scala. So we have in Hadoop, we have, instead of writing MapReduce applications, lengthy code, we have SQL, right? We have Hive queries. We can write a Hive, and we can write a pig queries, right? So these are similar to pig and Hive queries are queries are similar to SQL. Similar to SQL. So Hadoop, we have SQL support. We can treat like Hadoop data in a tabular format. Similar to this, Spark also has Spark also has Spark SQL. Spark SQL. So Spark SQL is similar to SQL. Similar to SQL. So Spark also has SQL query support. SQL query support. So Spark SQL is completely similar to SQL. Who knows SQL, they can easily understand Spark SQL. And main important one is Hadoop is not in-memory computing. Hadoop is not in-memory computing. In-memory computing. It is not in-memory computing. It uses both in-memory, and disk memory. It uses both in-memory and disk memory to process. Disk memory to process. Example. So MapReduce has two phases. One is mapper phase. So for mapper phase, we give input as HDFS file system. HDFS file as an input to HDFS file as an input to mapper. So we give HDFS file as an input to mapper. So assume this HDFS file has multiple blocks. So multiple mappers process this HDFS file parallelly. So assume we have 10 blocks. So 10 mapper instances created. 10 mapper instances process these blocks parallelly. So once mapper process, then result is going to store in a disk. So processing is happening in memory. Results are going to store in a disk. Then this data again transferred to passed to reducer. Reducer process this data and finally it stores in HDFS file system. HDFS file system. So it uses both in-memory computing and it uses disk memory computing for processing data, because all the mappers output, intermediate output is stored in disk memory, local file system. So assume if you have 10 mappers, 10 mappers data is going to store where? In local file system. So this result is again passed to reducer. Reducer reads that data from disk memory and loads into in memory and process it, and finally it stores the result back to HDFS file system. So it is not completely in memory computing. It uses both in memory and disk memory to process data. Okay. So coming to Spark, Spark completely uses Spark is a in-memory computing system. Spark is a in-memory computing system. Complete processing happening in memory. So first it reads data from disk and loads into in memory. Then it processes the data. Finally, whatever the location we display. So we give input is one storage system. So Spark reads data from storage system and loads into in-memory and process it, and it maintains results in in-memory. If you store this result back to any storage system, it will write the data into particular storage system. So complete processing happening in memory. In Spark, complete processing is happening in memory. So that's why Spark is 100 times faster than 100 times faster than MapReduce, 100 times faster than MapReduce in in-memory computing. In-memory computing. Spark is 10 times faster than 10 times faster than MapReduce in disk processing. So it is 10 times faster than MapReduce in disk processing. In in-memory processing, it is 100 times faster than MapReduce. And very important thing, very important difference is Hadoop has different technologies, right? Hadoop has MapReduce, Hadoop has Pig, Hadoop has Hadoop has I, Hadoop has some other technologies. Hadoop has some other technologies. We cannot include, we cannot, we cannot combine, we cannot combine MapReduce, MapReduce with Pig, comma Hive, etc. We cannot combine the code MapReduce with Pig, Hive, etc. We cannot combine. We cannot combine MapReduce code, Pig code, Hive code in a single program. It is not possible. You cannot mix with Pig with MapReduce, Pig with Hive. You cannot mix Hive with MapReduce, Hive with Pig, and you cannot combine these frameworks in a single application. So it is not possible. But we can combine we can combine Spark core, Spark core, comma Spark SQL, comma Spark streaming, comma Spark mlib, and Spark graphics programming in a single application. Spark graphics programming in a single application. In a single application. Single application. So we can combine all Spark components in a single application to provide solution to one problem. It is possible. We cannot combine MapReduce, Pig, Hive into a single program, but we can combine Spark mlib, Spark graphics, Spark SQL, Spark streaming, Spark core into a single application to meet our requirement. So we have Spark, Hive has Hadoop has Pig and Hive, right? So these are different technologies, right? So similar to we have in Hadoop Spark, we have Spark core, Spark SQL, Spark streaming, Spark mlib, and Spark graphics. So we can combine all these components into a single application. Single application. It is possible. So Spark has core components, Spark core, Spark SQL, Spark streaming, Spark mlib, and Spark graphics. So these are different core components of Spark. Core components of Spark. So we can combine all these components into a single application. It is possible. We cannot combine MapReduce in Pig, Pig in MapReduce, Pig in Hive, Hive in Pig. We cannot combine Hive code in MapReduce, MapReduce code in Hive. So this interoperability possibility is available in Spark. We can develop interoperable applications. Interoperable applications. We can develop interoperable applications using Spark. Example, I'm getting streaming data. What I'm getting? I'm getting streaming data. Streaming data. So I can use Spark Core. We can use Spark streaming to read this data. And I want to store this data, so that I use Spark Core programming, Spark Core. Then finally I want to convert to this one into tabular form. For that one, I can use Spark SQL. Spark SQL. So we can use, depends upon our requirement. We can use all these. We can combine all these programming into all these Spark components into a single application. So this is called interoperable applications. We can develop interoperable applications using Spark. And main difference is MapReduce is tightly coupled with HDFS. But but Spark can process any file system data. Spark can process any file system data. Any file system data. Any file system data. We can process any file system data. So Spark can process HDFS file system data. Spark can process local file system data. Local file system. Spark can process any RDBMS data. Any RDBMS data. Spark can process any NoSQL data. Spark can process AWS S3 data. It can process any file system data. It can process any file system data. It can process any file system data. So Spark we can run without Hadoop. Hadoop is not mandatory. To run Spark, Hadoop is not mandatory. Without Hadoop, we can run Spark. We can connect any file system or any storage, and we can process the data. But if you want to run MapReduce applications, we need Hadoop system is up and run, and MapReduce is tightly coupled with HDFS file system. It can process only HDFS file system data. Okay, and one more, MapReduce. We can run on Yarn only. Yarn architecture. We can run only on Yarn architecture. So from Hadoop 2.0, we can run Hadoop on Yarn architecture. But we can run Spark on standalone cluster. We can run Spark on standalone cluster, and we can run Spark on Yarn cluster. and we can run on Mesos cluster. Mesos cluster. So initially we start implementing Spark applications, and we can run Spark applications on standalone cluster. And next I will show how to run same Spark applications on Yarn cluster. So I'll show two architectures. I'll show how to run Spark applications on standalone cluster and how to run Spark applications on Yarn cluster. Okay. So Spark main component is Spark core. Spark core Spark core is a heart of Spark. So on top of Spark core, they developed remaining components: Spark SQL, Spark Streaming, Spark Emlib, Spark Graphics. These are implemented on top of Spark core. Let's open Paint and draw diagram. So main heart of Spark is Spark core. On top of Spark core, they developed Spark SQL, and they developed Spark Emlib, Spark Streaming, and they developed Spark Emlib, and they developed Spark Graphics. So on top of Spark, they developed what? Spark SQL and Spark Spark Streaming, and they developed Spark Emlib, Spark Emlib, and they developed what? Spark Graphics. So these four components developed on top of Spark core. We can run this Spark applications on standalone cluster. We can run on standalone cluster, and we can run on Yarn cluster, and we can run on Mesos cluster. So we can run on Mesos cluster. So we can run Spark applications on standalone cluster, and we can run on Yarn cluster, and we can run on Mesos cluster. So this is Spark architecture. So Spark core is main core component. It is heart of Spark. So on top of Spark core, they developed abstraction layers: Spark SQL, Spark Streaming, Spark Emlib, Spark Graphics. We can run these Spark applications on standalone cluster and Yarn cluster and Mesos cluster. We can run on all these clusters. Okay. So Spark programming in industry, they are expecting, if you are looking any jobs on Spark programming, Spark programmer, they are expecting Spark core, and Spark SQL. Spark SQL. If you know Spark core and Spark SQL, that's more enough. If you have a Spark core, Spark streaming knowledge, or Spark streaming experience, it's had an advantage. For Spark programming, they are looking only these three. So moreover, they are looking Spark Core and Spark SQL. If you are strong in Spark Core and Spark SQL, that's enough. So if you have a Spark streaming, it's add-on advantage. It's add-on advantage. So no one expecting Spark Emlib and Spark graphics. So Spark Emlib is expecting for machine learning developers. Spark Emlib expecting for machine learning developers. Machine learning means data science developers. So who are trying on machine learning or data science, people are expecting you must have Spark and Spark graphics. Spark graphics knowledge. So Spark graphics is completely graph processing. Spark Emlib contain machine learning algorithms. Okay. So these two are for machine learning and data science related and graph processing related technologies. And Spark programmer means who knows Spark core strong and Spark SQL strong and Spark streaming is strong. So this is additional. So people are expecting only these two. If you know strong in Spark core and Spark SQL, you become a Spark programmer. Okay. For this prerequisites for learning this Spark is prerequisites prerequisites to learn Spark is Scala language. Scala language and core Java. If you know core Java is optional. This is optional, but mandatory. You need to know Scala because we are completely implementing in Scala language. Next, add-on advantage. If you know Python, it is add-on advantage. Add-on advantage and basic Linux. Basic Linux. So if you know basic Linux, you can create a Spark cluster in Linux environment. In this our complete course, what we are going to use, we install Spark on Windows operating system. We install Spark on Windows operating system. Initially, we install Spark on Windows operating system, and we use IDE called IntelliJ, and we use build tool. We use build tool SBT. We'll discuss what is SBT there. Next, we use language Scala. We use language Scala for implementing Spark applications. So this is our environment. So we use what? Spark on Windows, and we use IntelliJ for programs development, and we use build tool called SBT for dependency or jar files downloads, and we use Scala language. So initially we implement a complete Spark core programming. So here our strength is not like discussing only transformations and actions. We will implement Spark programming, complete Spark programming in Scala. We implement Spark core programming. We implement Spark core programming. We implement Spark SQL programming, and we implement Spark streaming programming. We'll discuss all those concepts, including programming. And finally, we implement interoperable applications. Interoperable applications means we can combine all those technologies in a single application to meet our requirement. Plus, we'll discuss Kafka, and we'll discuss Kafka integration. Kafka integration. Kafka integration. We also discuss RDBMS integration and RDBMS integration with Spark, and we also discuss NoSQL integration with NoSQL integrations. NoSQL integrations. If time permits, I'll going to discuss S3 bucket integration, S3 AWS S3 integration, S3 integration. So we are completely concentrate on programming. Real-time examples will discuss different use cases. We'll discuss different use cases. That's it for today. We'll meet tomorrow